Okay, good afternoon. We've all been there, sitting, crafting every single line of code so neatly, so neatly. But when we look up, we see that all these nicely crafted pieces, how does the structure look when we take 2 steps back? And I'm very thrilled to hear what Chris Chedgey is going to share with us on how making that structure shine a little bit more than the nasty meth, at least I have ended up on occasion. Chris.
Thank you, Dan. Well, good afternoon. Thank you for coming along. Many years ago, I worked on this baby here, the International Space Station program. I was living in Canada, and I was working on these little robotic bits that are hanging off there. And it was really interesting to work. I'm sort of a pure software background, really. I was forced to do a bit of electrical engineering in college and stuff, but I was really a software guy. But to work with real engineers, right, who build physical things was really enlightening and a really interesting time. And they had pictures of what they were building. Right? This is what I love. They had documents, and you open them up, and there was these beautiful pictures of things like this. And it was like they just sort of spec'd it up, they did their analysis, they came up with diagrams and measurements and tolerances and stuff, and then they just went off and built it, and that was the sort of secondary bit. And of course, the software side was never quite the same, okay? The software kind of actually, in amongst all of that, of course, there's processors running software. But the software itself generally was more like this. It was the other way around. The software was the end result. It was the product, and the specs sort of happened a bit beforehand with loose words in them about what the software was going to do, but ultimately what it did was in here, okay? And more importantly, and we could test this, that was sort of okay, right? We live with that. But what I really want to focus on today is what happens when you have a lot of this stuff. When I've got a room full of like 50, 100 developers, and they're all hacking away on this stuff. What are they building? What's happening there? How do I find my way around it? Okay, and that's really what I want to focus in on today. Okay, and of course we have ways that we organize this, right? We don't just all sit around and hack away at one big file of source code, right? We do organize it. We organize it like this into these little dots that you probably can't see, or like methods or functions. And we put the functions into bigger buckets that we call classes or modules, okay? And that kind of helps, okay? So instead of all that code there, we got, thousands of lines of code, probably a couple of thousand lines of code maybe in this little set of classes and methods and things, and we can abstract about that. We can understand that, okay? And this is why we can understand it, because we can kind of collapse it down, and we have higher levels of abstraction now. Rather than just worrying about the code, we're thinking of the code in the context of something bigger, okay? But of course, it doesn't take very long before we get a lot of those little puppies, okay? And that's when things kind of go pear-shaped, to my mind. In the normal software project, we end up with a lot of these things organized in a structure of sorts that's very ad hoc, okay? So we do organize it in the Java world. You've got Maven projects, you've got jars, you've got packages, right? There's ways to organize your code, and we use those, okay? We use them a lot. But if we take a look at those items, if we start thinking of the packages now as our de facto structure, okay, our de facto design, if you like, it still looks pretty good. I've sort of just changed this tree view now and made it sort of two-dimensional. But what really is the killer is the core source code is unique in a sense in that it is highly interdependent on other bits of source code. Okay? And if we add in those dependencies here, okay, we see quite a different picture. Let's just zoom in a bit more. Okay? This is normal. If you look at any open source project with, it's a reasonable size, you'll see something that looks like this. everything depends on everything else, okay? And this is what we have to deal with. This is our structure. So really, mostly what programmers do is ignore this stuff. They kind of get used to where things are, which packages they're in. But mostly they're working in that ocean of classes. Okay? They're not really using, in any real way, the package structure. Okay? Okay. Why would we want something better? Well, if we had something better, it could serve as some sort of a roadmap for the developers so they can understand, find a way around stuff, okay? This is an important one, phased development, test, and release. Wow, that's what hardware engineers do, right? You never plug in built stuff that's been built out, you know, off-site or whatever, plug it into your piece of hardware and just start testing it. No, you wait until it comes and it's gone through a certain level of, you know, release and it's been given to you. It has to be built to be given to you. Software, that's not really the case. You can get any old stuff, right? But in order for that to happen, you have to have orderly dependencies. Okay? We could organize the work a lot more efficiently. Okay? Modularity. Okay? Mark was talking about some of the real hard benefits to modularity, okay? But there's one big one there, which is divide and conquer. It's how all engineers do their stuff, okay? You hide some of the stuff you don't need to do, you expose some interfaces, and that just makes everything so much easier, okay? Reuse or replace subsystems, okay? Impact, regression control. Do you know what's going to change when you change a particular component? Change some code in a package. Okay? Yeah, you usually do. You make the change and you see what breaks. Okay? But would you like some sort of idea as to what could change? Okay? New developers, what do? Well, what they usually do is you give them an IDE, you point it at the code, they do a git pull, and they take a lot of time from your senior developers, getting them up to speed. Okay? This should be helping them. Okay? That isn't helping them. Okay? So, what's the story? Why is this really worthwhile? If it was just a mess, I wouldn't be standing here really, and as if there was nothing to be done about it. The thing is, it's avoidable. Right? If you had a junior guy came onto your team and he created a class with 1,000 methods, or one method with a cyclomatic complexity of 280, right? You'd have a conversation with him. You say, don't do that. And you're not just having a conversation to make him feel bad. You're having a conversation because you want him to stop doing that, because that method is very expensive, okay? And not only that, it's easy to avoid putting that much stuff into one method. You just split it up into multiple methods, okay? Here's two organizations, package structures for the same piece of code, okay? We've just put stuff into different packages. On one side, you've got something that's really easy to understand. I can easily see the overall picture of the code base, what uses what. When I change something, I kind of know where other things are likely to change. The thing on the right-hand side, I don't have that, okay? I don't have that luxury. It's really just a mess. And again, the one on the right-hand side is probably the more normal, and I'm mostly not going to be using that. My team are not going to be using that in any meaningful way. Okay? What they're going to be doing is in the code, hopping from class file to class file to class file. Okay? So, what is structural beauty? So I'm going to go through just some of the key, I think I've got 4 or 5 of the key attributes, if you like, of structural beauty, if you like. And I'm just going to sort of outline those here. And then I'm going to show you sort of interactively a bit more about each of those. So I'll elaborate on them. First one I've put up here is enough containment. Okay, so structure comes from containment. Okay, so we've gone from all those little lines of code and contained them up in various ways. You need to do that. You have to organize. You can't just stick with, in this case, this is a package, let's say, with however many, a couple of hundred classes, right? And the associated dependencies, okay? Don't give me that, okay? Break it up. So first thing you need for good structure is some structure, okay? So we need to divide stuff up. Okay. Second thing we need is acyclic container dependencies. Now, put this way up there on the list. If you've got a highly cyclic package dependency relationships in your code base, the other things don't really matter too much. Okay, this is the first thing that you kind of got to get right. Okay, those cyclic dependencies are what Mark was referring to earlier on, where you want to kind of push stuff out of the system. Okay, try pulling stuff out. If it's cyclically in the middle of a cyclic dependency, you have to pull the whole stuff with it. Okay. Coupling and cohesion. Okay, this is real motherhood and apple pie. Remember these words we heard in Software Engineering 101. Coupling and cohesion are two sides of the same coin, right? What you want to do is, as much as possible, get the siblings within any scope to be cohesive, okay? But you want the containers themselves to be loosely coupled. Okay? If you do one, the other kind of follows, okay? So there's a kind of an example here where you've got a couple in the top expanded package there. You've got a couple of groups of packages, likewise down the bottom, that are not connected to each other. And what we'll see later is when you put things together that are connected, you'll find that the containers themselves are less tightly coupled. So you want to get dependencies as close as possible in your structure. Keep them tight, keep them local. Next thing is look at what is being used at every scope. Okay? Think in terms of modules and information hiding. Okay, is there stuff that you can that is being used but not being used very much from outside? Okay, one thing I hate to see is you've got a package structure and you look in every package and everything in that package is being used from the outside. Right? Same as a class. When you look at a class, because it's part of the Java language, I think we do this more intuitively. You expect some things to be hidden inside, and it really helps you to understand what's being used from the outside, where's the control flow coming into your class, and then it's hanging around in these internal implementation methods. Okay, that really helps, but it also helps decouple, right? It helps hide some of the logic, some of that complexity, so that change isn't as disruptive. And of course, it's always nice to build things the right way from the get-go, okay? But sometimes reconstructive surgery is necessary, okay? If something isn't born beautiful, sometimes it can be made beautiful. And I'll talk a little bit about that, okay? So first thing I just mentioned is you are going to need a different tool. Your IDE is not going to give you this information by default for the most part. Some of them do give you some additional tools, plugins and so forth. But you can't expect you or your team to do good structure if they can't see the structure and the structure emerges from the code. Okay, you can't just see it in the code. Okay, it's not possible. So you need something that will parse the code. It needs to basically show you a hierarchical dependency model, okay? And it needs to be malleable. You need to be able to try different things out, okay? Few options out there. Sonograph uses these kind of things here. They're a type of hierarchical dependency graph. There's another tool called Lattice. IntelliJ, IDEA Ultimate have these things, dependency structure matrices. That kind of thing is what you need. And Structure 101, which is my baby, uses these things called levelized structure maps. Okay, all of these have their own pros and cons. You want to get one, and there are certain freebie analysis tools, JDepend you've probably come across, that give you aspects of this stuff. So what I'll show you today will be Structure 101, but the other one, what I'm going to show you is a subset of it, and it'll be, you do the same stuff with other products also. Okay, so let's go take a look at that. So, first thing here I'm looking at, oh, that's not what I meant to do. is I just show you a quick scan around, if you like, a counter pattern. Okay. Then I'm going to show you a good code base. And then I'm going to go through a bunch of fudged up example use cases to give you a bit more of an understanding of what I'm talking about. Okay. So this one here is it's just a random piece of source code, and okay, it's not going to resize. Okay. As you can see, there are 3 jars, and I just drill in here. Okay, this this red zone here it's just a group of things. It's just they're pulled together. It's pulled together cyclically dependent items at any particular scope. So you can see here, there's 3 packages that are cyclically dependent. And if I drill inside one of these here, I see another one here. It's got 8 packages are cyclically dependent. If I look inside one of these, I see there's another 2. Okay. If I go inside here, I see there's another 3. Okay. This is tangles within tangles within tangles. This structure isn't going to help anybody do much. Okay. It might help them find a file if they're in a race to find a particular file or something, but that's about it. Okay. Let's take a look at another one. Spring framework. The Spring guys monitored their package dependencies from the start. Okay. Every build, they check, are there any cycles? Okay. There are free tools to do this for you. If you did nothing else but instigate this policy, no cyclic dependencies between packages, you'd be amazed how much stronger your code base would be. Okay. How much easier it would be to find, which is, after all, the purpose of the structure. Okay. So here, what you may not see there is that all of the dependencies here are flowing downward. Okay. So I'm actually going to switch off those dependencies to show me the dependencies on the selected items. Okay. And I can see here, everywhere I go, the dependencies are all flowing downward. Now, this is really important. It means that from one glance, I can see exactly what is or could be using every package, okay, and what every package uses. There's a flow down, okay. And if I look inside here, I'm going to see the same kind of thing, okay. JDBC. Core. All these sub-packages, okay. All the dependencies just flow top to bottom at every scope, okay. JMX. Support, okay. So you can see that really easy to understand, okay. Well, let me put it to you this way. It's a complex piece of code. Code is difficult to understand, but it's much easier to understand when you've got a cogent structure, and particularly an acyclic structure. So let me go through some of those beauty attributes that I mentioned earlier on, okay. First one I talked about was you got to have some structure, okay. Got to have enough structure. Let me show all the dependencies here. So here's not a particularly big package, but I've kind of combined a bunch of packages for demo purposes. And you can see, to me, there's too much stuff here. I mean, you can measure different ways of measuring how much stuff have you got any one place. The idea is, obviously, it should be a mind-sized chunk. It should be stuff that I can look at and understand, say, what is the purpose of each package, where is it in the dependency or usage hierarchy, etc. Okay? That's too big. So the first thing I'm going to do is organize those classes into something a little bit strange going on with my okay. Let me just go back here. I think there's something a little bit strange going on with the overhead projection system. At least that's my excuse. Let me try this again. It's just not showing it. It's interesting. Let me just restart this project here. Okay. And then we were looking at this one here. Okay. And so the first thing we want to do, which it might do this time, is organize all of those into what I've done here. These are leaf packages. Okay. So each one of these packages has some classes in it. Okay. And the idea would be each one of those is a sort of a mind-sized chunk of stuff that I can understand in its own right. Okay. And I might decide, well, actually, that needs a bit more organization. So I need to organize the packages into some higher level packages. And I end up with something that looks a bit like this, okay? And I got a combination when I look inside each of these. There's some, packages, higher level packages, etc. Okay? But all of it is sort of now mind-sized chunks, and crucially, is acyclic. Okay? Organizing stuff into mind-sized chunks is actually quite easy. You can do it alphabetically. Okay? Take all your classes and put A to be in one package, and etc. Okay, but do that acyclically is what we want. Okay, so that's grand. Let's just have a look why cycles are so disruptive. Okay, so I'm going to have a quick look at that. Let me try 3, 4. I'm just trying to find my little pre-canned example here, and I believe that it is to beauty. Here we go. Okay. And we do an undo. So let's go back here. This is the kind of well-organized structure that Spring has given us. And as you can see, all the dependencies flow down. So I'm actually going to go back and just not show all dependencies all the time, just show them when I select stuff. And you can see here, as we saw before, dependencies all flow downward. And so when I select HTTP there, I can see immediately what uses HTTP. So I'm going to do some work on HTTP. These may be other team members or other teams, depending on size of your code base, but I can see immediately, because my package structure has some meaning, it's used as part of my process, I can see that HTTP immediately is used by web, mock, and test. Okay, and indirectly, it's used by, web is used by remoting, which is used by EJB, etc. So I can actually do a quick look here. If I select that and do this, you can see there the selected items there are what could be impacted if I made a change to HTTP. Now, let's say that I make a change to the code. Okay. So what's happened there is somebody in the last build has made a change to the util code, and it now references something in EJB. Okay. So if I now do that again, what is it that could be impacted? I see nearly everything can be impacted. Okay, and this is normal. This is the norm in terms of the packages. Okay. That's why people don't use a package, because you're saying, well, yeah, but the code level, what really is used. So now you're back into that ocean of classes to understand what's going on, okay? But if you start treating your packages as true abstractions, then this is the impact of that particular, that new piece of, that code change that just went in, okay? So that's one reason, okay? There are lots of reasons. And of course, this change, that probably is quite an easy one to back out. It just came in the last time round. The problem is when these are all over the place, okay? They're so disruptive, I like to call them the structural go-to statement, right? That's what these things are, right? It just hyperspaces you to a different location in terms of understanding how stuff hangs together, okay? Okay, now let's go to 3. I don't think there's a 3. Let's go to 4. So, next thing we talked about was coupling, cohesion, and the sort of interaction of those two, okay, how they relate to each other. And in particular, how thinking about keeping your dependencies local is so important, okay. So I'm just actually here, I'm just going to switch off the names here because they're not really relevant at this point. I'm going to go, okay. going to take a look inside here and inside here. And then I'm just going to switch on this little option here. So what am I seeing here? What I'm seeing here as well, there were 4 packages at this scope that I'm looking at, okay? And I'm seeing the top package here has 2 groups of stuff that have been indicated. These 2 groups don't actually use each other. In fact, these 2 here, it's a group of orphans that don't use each other either. So there's actually 3, sort of, there's a package, there's 2 packages here, and this package that have no interdependence with each other. So they've somehow ended up in the one, and this can happen if it's a library package or what have you. You can have, you have fairly disconnected group of items within it. But what's happened is, anyway, for whatever reason, they're in here and they don't depend on each other. And likewise down here, okay? Now, what's interesting that I notice is this group of packages here is used by both of the disconnected packages, sets of packages, in the higher level package, container package here, okay? And this one here is used by neither of them. Okay, so I've got quite a lot of dependencies going on here. Let me just show all the dependencies here. So I've got a lot of dependencies. I don't know if you can see those. I'm quite faint. Let me make them bolder. There's quite a lot of dependencies crossing this boundary here. Okay, and that's what we don't want. Okay, that's non-local. That's going remote. In order to understand really, this piece of functionality, I need to look at the code in these packages and note that, it uses some stuff over here, okay? And that's sort of going remote. It means I'm inside this. Now, what's this whole package doing? And I'm starting to think about what's in, what are all these things doing, which are not really related in any way, okay? Whereas if I move these 2 packages up inside here, notice what happens. Now, okay, what have we got inside here? There's a couple of classes, okay. Now what's happening is in both of these 2 packages where we did have groups of disconnected stuff. So I just did an undo there, right? Now I have both of those packages are fully connected. They're cohesive. Okay? So that's good. Okay? Now I don't have to go so far to figure out, to understand the code in the packages that were in the other parent package, if you like. Okay? The other thing I'm noticing is that now, where before this package here was dependent on this package here, okay, now it isn't, okay? This is out on one side, okay? So I should probably come up with a good measure for this, some sort of like make it look more scientific, but I'm sure there's a measure you could envisage which looks at the number of local dependencies versus the number of remote dependencies that go to some other package, some other scope. And this would be much better. Okay. Okay, so let me just go one more. Let's talk a little bit more about cohesion. Okay. This is a similar situation, but I want to look at it from a slightly different point of view. Here you've got groups of packages here, and if I look at each one of these and look at the contingent dependencies, if you like, okay, this one is used by these 3 packages at the top all use this expanded package in question, but they're using different bits of it, okay, and they're using, as you can see here, 1 uses that, 2 uses that, 3 uses that, and this group here, 3 of the other packages use that, okay, or actually 2. Okay. The effect of that is that there's a lot of if you use a small piece of functionality out of the whole of the package that you're using, okay, the granularity of your dependencies is not great. Okay, and in a sense, particularly when these things start being built into your process, which is what we ultimately want, you're going to end up retesting stuff unnecessarily, for example, okay? But even just thinking of it from an aesthetic point of view, in the sense of your developers trying to understand stuff, okay? They're understanding this as a package that does some things, and all these things use this big abstraction, okay? Whereas in fact, in each case, they're just using a little subset of the behavior that's happening inside here. So I'm going to do another thing here. If I just sort of select all of those, if I just select this and I'm going to do what's called tagging, just puts a blue dot on them. Now, if I get rid of that package and pull up those sub-packages, I'm going to get a much tighter granularity of dependency. Now each of the things is depending on the blue dot item that it depends on, but not the others. Okay, so that's just sort of give you an idea that there's a cost to having disconnected items pulled together that are not really related to each other. Not just that your abstraction's kind of messed up, okay, but also the things that depend on that abstraction are are harder to understand. Okay? And sometimes it's better to break things up. Don't have too much structure. If things are not really connected, break them up in that way. Okay, stop talking about that now. And move on to interfaces I talked about. Okay, so again, we're not showing the names here. This is a quick one. Just to highlight here, you can see the external dependencies coming in here are on code in these two leaf packages, this one and this one, okay? So you got 3 dependencies on this, and then one of those items is dependent on something inside here, okay? This is worth keeping an eye on, okay? And what I like to do is keep an eye on new package level dependencies, period. So every time there's a new dependency, hold on a second, is that going to the right place, okay? Why is there a package dependency today that didn't need to be there yesterday, okay? And what you might find is that, well, either the dependency is not required, make the code different, or perhaps it's worth taking the class that was here and moving it into an interface package. Okay, don't get carried away so that you got your interface package should be an abstraction in its own right. You don't want this driving your whole package structure. So you've got interface implementation. I hate seeing that because you'll need to be thinking of object-oriented abstractions rather than that kind of enforcement. But it's something worth keeping an eye on, because now I've got this situation where the only thing that is used, anything that's used, is this one particular entry point, and the other things are all internal. And you can actually set up, there are tools to set up enforcement of that, okay, so that nobody starts using the code down here, and that's moving us a step closer towards true modularity, okay, which is what we want. Okay. And 2, 3, 4, 5. I think that's it on this front. Now I'm going to sort of pull all of this together, okay, and show you a little bit of reconstructive surgery on that original project that I showed you. Okay, so let's go back to here. Save changes, nope. And let's show our names again. And show the dependencies. Okay. So if you find yourself in the very usual situation of having a code base in your that has very tangled package structures, what can you do about it? There's basically two approaches that I would follow. One is look for ways that you can manipulate the structure as it is today in small ways. Excuse me. Where are there places where you can make small, ideally moving classes or packages between parent packages? Okay, are there places where you can do that? And that's real low risk if you can do that. And in the process of doing that, remove some of these cyclic dependencies. Okay. Second thing you can do is actually do some refactoring to remove the cyclic dependencies. So you're saying, well, these classes are kind of in the right packages. Problem is my code isn't really very good there. Now, if you've been working on a code base for probably several years, a lot of people, to come at it too much from that angle and get all purist about what the design should be can be an expensive activity, right? So saying, I'm going to get rid of this dependency now. Wow, that can be quite, there could be 100 references from one package to another. Okay, so you're much better if you can move the classes around, come up with a different package structure rather than change the code to match the package structure that you currently have, if you like, okay? Here's a case, I'm just going to highlight the cyclic dependencies. So in this case, I can see that there's some orphans here that are using this faces package here. And nothing else, because they're orphans at this local scope here, right? Nothing else at this local scope is using them. They have a two-way dependency with this particular package here. I'm going to say, you know what? They want to be in there, put them in there, okay? And now my util package, very common one to find, your util starts using other stuff. Everything uses util. So if your util starts referencing, was it the java.base that Mark was talking about earlier on? You've got a big problem. Okay, because you're going to have, that's going to just drag everything into cyclic dependencies, okay? Here's another one, okay? A couple more here. Here's a whole package that has a two-way dependency on this faces package, but only one-way dependency on everything inside the messaging package. So I'm just going to move that up there. Here you've got this one here. It's a tangle of 3 classes. It is implied if you have a tangle of classes, you can't move those classes around into an acyclic package structure unless you bring them all together, okay? So you either, this is particularly important, a smell would be 100, 1,000 classes. I've seen 4,000 classes in one big class tangle, okay? You can't, no matter how many times you move those around between packages, those packages will be cyclically dependent, okay? So you would have to either put them all in one place, ring fence it and say, let's not touch that for now, okay? But let's not let it get any bigger, okay? Or you have to start getting into the code and busting up the big class tangles, okay? In this case, it's a little class tangle of 3. So I say, well, we can just move that fellow up there. And now net has fallen out of the tangle, okay? Let's look inside faces. Here's a tangle of 14 items, okay? Again, there's a util and a quick looking around. Event can come out. I think DOM utilities. And what I'm looking for is things that use core utilities, use other things, okay? Because util shouldn't be using other stuff. So I just pulled them out. For now, they're hanging around at this level here. You know, they'll end up somewhere nice. But for now, get them out of there so that the util stuff is now free. And my tangle just got a little bit smaller, okay? I can do something similar in here. Okay, great. There's an incoming dependency on an orphan, so I can move that out there. And now facelets fell out, okay? So what you're doing here is you're looking for examples, low-hanging fruit, if you like, where for an item to be held into a tangle, okay, it has to use stuff in the tangle, and it has to be used by other stuff in the tangle. Okay. If you can break either the incoming or the outgoing dependency there by moving some stuff around, then it will be freed from the tangle. Okay. So that's the kind of thing you would do there. And this is what I would call top-down, right? You're starting with the existing structure and seeing if you can make a bit of progress without, with minimal disruption to the current package structure. Okay. So let's jump forward. We do a bit of that, and let's say we get to something that looks like this. Okay, so drill in here, and so this has been tidied up, and this has been tidied up to this level, but inside core, we've still got this tangle of 14 items, and when we look inside, you know, we've got what I showed you earlier on, really, is this tangles within tangles, etc. Okay. So, and we do a bit of messing around, we move things around, we decide, you know, life's too short. This is going to take me the rest of my natural life. I'm going to, I don't really care that much about the existing package structure or whatever. I can do some more draconian surgery, and we can just say, okay, let's start again, okay? So how do we do that? Well, we can simply flatten that to the classes, And this is all the classes now flattened into a single package. Okay, so I get rid of all the packaging in here because it's a mess. Okay, and it's just pulled it all together. And now it's too big. Now this is a big fat package. Okay, this is a lack of structure in here. But it is what it is. Okay, so now what I can do is I can kind of look for items within here. I don't know, servlet relate. This looks like a servlet related thing, another servlet related thing. What's that? Another servlet related thing, and I can wrap those into servlets. Okay, etc. So I can go through and I can sort of find some. I can find things that are common that are in the same kind of area at the within the layering. Okay, what doesn't work well is to take something from very disparate layers. So say something like this. If I take, I don't know, let's make sure I get something that breaks. So I drag this thing up here and put it into servlets. Ugh, that's going to cause a big tangle. Okay. Because you need to have stuff that's some way related, right? You don't have stuff ending up both dependent and depending on other items within in a tangled way. Okay. Okay, so I could do that, and that would take quite a long time. You could also do that sort of semi-automatically, which is, I think, a great way to do it. And if you treat this, you need to treat this with as what it is. It's a sort of a magic algorithm that just goes through and finds cohesive clusters of stuff and puts them into packages in the model. This is just a model, okay? Okay, we can export an action list later if we want to. What we're trying to find is what does it come up with, and in this case it suggests that this is a package of sorts. And what's this? Servlet related stuff, so I would rename it. It gives it just sort of automatically generated name just to indicate the size of it, basically. But that'd be servlets. And then what have we got here? This is, I don't know, file related. Rename to file related. Files, etc. Okay. I might go inside here. Thing is, this is what I'm going to call this renderers or something. I'm not. What I'm saying is, it's very hard to do this at an angle. Anyway, etc. So this is renderer stuff. I probably would override it. So in this case, I see there's a bunch of renderer stuff in here, and I would probably grab their other render hub. I might say, well, that belongs in there. And what else have I got? Any other renderers? Render thread. I pull that in there, etc. And I might say, well, you know what? That doesn't need to be at that scope. I might move it to that scope. But the thing is, what this has done is it's just given you a means. Well, you're just start thinking of this stuff. It's flexible. This is cheap, right? Rearranging things into a new package structure doesn't cost too much. Okay. Yeah, okay, we're going to get into build systems and unit tests, harnesses and stuff like that. But other than that, it doesn't cost you too much to move things around. So find a structure that is either close to the existing structure or is a completely new structure and get your code base into that shape, doing this kind of manipulation and moving stuff and grouping existing code. Your code is what it is today. Try and avoid refactoring too soon and get it into a structure that is at least acyclic in its own right. Anywhere there are large class level tangles, they're grouped together in this way, okay, within one package, okay, so they don't cause package level cycles. And you're already a long way down the road. Okay. The worst case is you may well have a few areas where you think, you know, as I was doing this, I did notice that we've got all this muck in one place that really shouldn't be in one place. And I need to go off and do some refactoring on that. But that's good, right? At least you've contained it. And it's not going to get any worse as long as you keep monitoring it. And you know that it's there and you know what your problem is. Okay. So. Okay, I'm going to, at that point, I think, leave it at that. Hope it's given you a flavor. Oh, I could go to my ta-da version of this particular project. So here we go. And you can see, basically, this is what I, after whatever, a couple of hours work or whatever, I ended up with something that looks kind of like this, had effects in the middle and sessions. And so each one of these has a sort of a civilized amount of code in it. It's a mind-sized chunk and it's all acyclic compared to, if you remember the way it was before, lots of sort of convoluted nesting and nesting of tangles within tangles. Okay. So at this point, I think we're about 5 minutes from the end. I think I might pause at this point and see if you have any questions. I jump back to here and then go to here. Okay.
Yeah, hello. That seemed to be a very nice way of fixing problems when they already exist, but I have an opinion that pretty well divides people into haters and lovers. I like to prevent this from happening by keeping pretty much the package equals module, because build systems don't allow cycles between modules. So are you a hater or a lover of that idea?
A bit of both. That's good, right? And you use Maven or what have you at your top level breakout is good, okay? Where it becomes a problem is that you deceive yourself that you've got this nice acyclic structure, but there's like 2 million lines of code in one of those Maven projects. And that, to me, is too much stuff to be left without a structure, okay? So other than that, I'd say go for it. But either continue to drop the level of, increase the number of Maven projects as your code base grows so that you have an acceptable lack of structure, okay? So none of those projects are getting too big. You haven't got uncontrolled zones of 1 million lines of code. It could be, yeah.
Okay, a question. I've sometimes tried to break circular dependencies by sort of replacing one of the dependency with a kind of a callback interface. So what do you think about that strategy?
Yes, you can do that for sure. I'm always nervous of doing too much. What I would be asking myself there is, am I putting in too many interfaces? Okay, in order to sustain an existing package structure which wasn't particularly well thought out in the first place. And interfaces themselves, if they go rampant, don't necessarily help you understand. They're sort of, you're pushing a lot of the dependencies to kind of runtime almost, and I think that can be a problem. But where you've decided that your package structure is good, Class A and Class B are both in the right packages, but A should not be using B, then why not interface it out if that seems appropriate? Yeah, that's a perfectly good way of reversing the direction of dependency.
Okay, I think we're actually out of time here, and
Okay.
it's time for a break. So thanks a lot, Chris.
Thank you.